Hey y'all, so we're going to go ahead and start chapter 12, part 2. So this is going to be reactions of the functional groups that we've learned in this chapter so far. Specifically alcohols, thiols, aldehydes, and ketones. We're not really going to learn any reactions with ethers. So this is, I think the lecture material will just be the 17th and the 19th, and then the 22nd we'll do a lot of problem solving to help push in these reactions and help you understand them. So all of this content is chapter 12.4. So it's a lot of content for one section, but and then I have some practice problems here from the book for you guys to do, and there'll also be practice worksheets on Canvas for you. So the 4 reactions that we are going to learn in this class learn in this section, the 4 reactions are combustion, dehydration, oxidation, and reduction. So as we go through these reactions, you'll see how there's some comparisons and contrasts with the reactions we already learned of alkenes in chapter 11. So let's go ahead and start with our first reaction, which is the combustion reaction. So we already talked about combustion of alkanes. So now we're going to talk about combustion of alcohols. So it's actually the exact same as alkenes. We just have an alcohol to start with. So our balanced chemical equation is going to be a little bit different. So we're going to have our alcohol and add oxygen, O2, and that yields CO2, water, and heat. Okay, so let's go ahead and practice balancing one of these chemical equations, chemical reactions, so that, but we're not going to do too many examples of these because it is the exact same as what we learned previously. So first, let's look at our carbons in our molecule here. We're combusting ethanol here. So in our molecule, we have 2 carbons on this side, but only 1 on this side. So we need to put a 2 in the front of CO2 to make that equal. Now let's look at our hydrogens. We have 6 hydrogens on this side of the equation, but only 2. Let's put it 2 times here. But only 2 on the right side of the equation, the product side. So we need to multiply this by water by 3 in order to get our number of hydrogens to line up. And then lastly, let's do blue, our number of oxygens. So we have 1 oxygen here and 2 oxygens here for a total of 3 on the left side. That looked pretty wimpy. 3. And then over here, we have 2 times 2, so 4 plus 3 equals 7. So how are we going to put our coefficients in here in order to balance this out? So we have 3, but we need 7. So if I put a 3 in front of the O2, then I have 3 times 2, which is 6. Let's change how we wrote that real quick. 3 times 2, and that equals 7. So if I put a 3 in front of the O2, then my math checks out. It's a little bit of a game, a puzzle to figure out the numbers here and the math here. But yeah, so that's how combustion works of alcohols. It's the exact same as alkenes. And the main thing that we'll be doing with that is predicting the products or the starting materials or writing out the chemical equation and balancing it. Okay, so we'll continue on with the next reaction in the next video. See you guys.